Math 2, Unit 4, Fall Final Review. When I think about Chapter 4 or Unit 4, and remember this video is really an overview of Unit 4. It is not as detailed as each of those sections. If you need any section, feel free to go to the video on my website that has that particular section, because there's a 15-20 minute video that goes into detail for each section. Look at that if you need it. Otherwise, this is really a summary of what we covered in Chapter 4. When I think about Chapter 4, it's all about triangles. You have to know certain theorems about triangles. The first one is called a midsegment triangle midsegment theorem. Let me zoom in on this so you could see it. The midsegment is when you go from a midpoint to another midpoint on the triangle. What you learn when you go from a midpoint to another midpoint is that is a midsegment of a triangle, and it is exactly half of the length of the side it is parallel to. This AB is twice as long as that length of DE. That's a midsegment. It's half. Because it's half, you can think of it as if I double this middle, it's equal to the bottom. Sometimes it's easier to solve it that way. It's up to you how you solve it. Then you had to learn other things about triangles. First and foremost, what happens if you did a perpendicular bisector? What does it create? And then something called an angle bisector of every side of a triangle. The first thing is that you learned anything that is a perpendicular bisector is equidistant to the endpoints. These two distances would be the same as each other. From here to here would be the same distance as each other. And if I even change the point over to here, that would be the same distance to B, and from there to A. It doesn't matter as long as it's on the perpendicular bisector. Which created, if you did the perpendicular bisector of this side and the perpendicular bisector of this side, it creates a point called the circumcenter. The circumcenter is the point that is equidistant to the vertices. If this distance and this distance and this distance is the same, then guess what? That creates a circle that circumscribes the triangle. That means it goes through all three vertices. Those are going to be the same because it's created by the perpendicular bisectors of each side. If you did angle bisectors, on the other hand, the angle bisectors, if I bisect that angle and that angle and that angle, those three lines cross each other at a point called the incenter. And the incenter is equidistant to the sides on the inside, which is also perpendicular to the sides, but it's not a bisector. So I have to be able to know that this is different than the one before it, the one I showed you before. It creates the circle, the center of the circle that touches all three sides perfectly. Angle bisectors create this point called the incenter, if you extend them. Perpendicular bisectors create something called the circumcenter. So there are two other things that can cross that will create two other names and shapes, most of which will come from Section 4. Section 4 are medians. Where medians intersect, they cross at a point called the centroid. A median is defined as a point that goes from a vertex to a midpoint. These would be equidistant. That's a median. Medians cross at a point called the centroid. Altitudes that are perpendicular to one side, they all cross at a place called the orthocenter. This one is not a main idea. It was just another name of another place that is concurrent with each other. What we did with the medians, centroids also split the median into 2/3 to 1/3, or from 1/3 to 2/3, depending where you were. From the centroid to the midpoint, from the centroid to the midpoint is the 1/3 part. From the centroid to the vertex is the 2/3 part. 1/3, 2/3, 1/3, 2/3. We could do a variety of problems where we give you one part and ask you to find the other two. That's what we did back then. And then we really had to know, what were these called? What were they created by? We had to know not only what were they called, the lines that created them, we had to know what their names were too on the inside. The last thing we had to know about triangles were these inequalities. Inequalities, because you had to know how you could make a triangle. You also had to know which one was the smallest angle and the smallest side, because the largest angle would always be across from the largest side, and the smallest angle would always be across from the smallest side. Think about that. As an angle gets bigger, the side across from it gets bigger. That's exactly how it's created from a triangle. We also could tell whether you could make a triangle using an inequality called the triangle inequality theorem. The sum of the two smaller sides has to be greater than the third side in order for you to create a triangle. We would not be able to create a triangle out of 2, 3, and 7 because 2 plus 3 is not greater than 7. It wouldn't make a triangle because 7 units is really, really far away. Look at how far away. 2 and 3 can't touch if we're end to end. It doesn't work. We found possibilities with inequalities, possible lengths for the third side. Not a main idea, but we did do a lot of problems where we subtracted those two values and added those two values, and our range was between these two things. We would write less than and less than to say it's going to be bigger than this difference and smaller than the sum. And then we could figure out what the largest angle and side length was in two triangles if we needed to. That was not a main idea, but we threw some of those problems in there as well. If I were going to say what's the main idea of this chapter, you had to know this whole mid-segment thing, be able to do problems there, and then the 4 different perpendicular bisectors, what they create, angle bisectors, medians and altitudes, plus what do centroids do for the problems, and knowing the difference between all of them. If you need more examples, you're going to get some problems in your worksheet, but otherwise, that's Unit 4.